Hi, in this video we're going to take a look at the next topic in the coordinate geometry, and today we're going to focus on the line and a point on a plane. Last time we focused on explanation what the plane is, and specifically what the coordinate plane is. We understood how it arises, and we understood what does it mean to mark a point on a plane. And in this video I wanted to focus on this a little bit more so that we can understand how points are used to form lines. So I'm going to mark a point on this plane, and I'm going to read out its coordinates. So again, just remember that the horizontal axis by convention is called x, and the vertical axis by convention is called y. And by convention, I used ordering to know which coordinate corresponds to which axis. So the first coordinate, the first number that I read out, is usually read out from the x-axis. And the way to do it is something like this. You can either just use your eyes, or you could follow this procedure. You draw a line that connects the point with the x-axis in such way that the angle between the line and the axis is 90 degrees. So we draw a perpendicular line connecting the axis and the point. And the place where the line connects to the axis tells me the number that I use as the x-coordinate. So in this case, x-coordinate is equal to 4. And I'm going to follow exactly the same set of steps to find the y-coordinate. I draw a line that's perpendicular to the axis, and I'm going to read the number on the axis where the line that I draw, line that connects the point and the axis, touches the y-axis. So that number is equal to 2. So coordinates of this point are equal to 4 and 2. Again, I drew another point over here, and I have entered the coordinates for this point already. So just as a matter of practice, note that if I draw a line that's perpendicular to the x-axis, it touches number 3, and that's why number 3 is used as the x-coordinate. And in a similar way, I draw a line that touches the y-axis at number 2, and that's what 2 is the y-coordinate. If I add another point with coordinates 2 and 1, what I notice is that I can draw a line that goes through those 2 points. And here is something that we need to remember. Line can be drawn on a plane if you have 2 points. So any 2 points on a plane can be used to draw a line. What that means is that if I have 2 points over here, then I can draw a line through them. If I have 2 points over here, I can draw a line through them. And I can connect any of the points that I already have on a plane with another line to form a whole mishmash of lines on this particular plane. What follows is that you can only draw a line through 3 points if they are on the same line. So the minimum and the only requirement for line drawing on a plane is to have 2 points. And if you have 3 points, they can be connected with a line if and only if they're on the same line. But that's not that important yet. I just need to be aware of this further on. So I'm going to draw a line through these 2 points. So these are the 2 points with a line on them. And I'm going to figure out what does it mean that those points are connected with a line. And not only those points, but there's also this point is on the line. This point is on the line. This point over here. And all the other points in between. And there is actual way to find the relationship between the x and y coordinate that arrives at this drawing, that helps us to draw a line. And that's something that we understand as a pattern. So let's see. For this point over here, the x number is equal to 3. The y number is equal to 2. The question is, what do I have to do to the x number in order to arrive at the y number? Well, I have to go to x number minus 1. So I take 1 away from my x number to get the y number. Let's see if the same pattern, the same principle holds for the second point. So I start at the x number is 2. Y number, is it equal to x minus 1? Yes, it is, because it is equal to 1. So the pattern checks out. Let's see the coordinate. Let's see what would this look if my x number was equal to 1. Y number should then be equal to 0. Let's see, does that match on the graph? Actually, this point with x coordinate of 1 has y coordinate equal to 0. So the pattern matches. And I can follow this for all the numbers along the x line. And if I did this for all the numbers along the x line, what I would end up with is this line. So the pattern that describes the way the line is formed can be called the equation of a line. And you obviously are familiar with something like that. And for this line, the equation of a line would be y is equal to x minus 1. We take the number from the x-axis, we take 1 away, and we end up with the number for the y-axis. And this thing is the equation of a line. That's something that we're going to be using very extensively going forward, but I'm just going to talk about it briefly. So this is one equation of a line. And this equation of a line actually consists of a couple of elements. So if you look at, again, my equation, y equals to x minus 1, it looks something like this. In front of x, we have number 1, so that's y equals to 1x minus 1. And after x, we have this little constant. And those two numbers, the m number and the b number, they have their own names and they change how the line looks on the plane. So I'm just going to show you what happens if I vary each of those numbers. So first, let's see what happens if I vary the m number. So you notice that if I vary the m number, the steepness of the line changes. If I increase the m number, the steepness of the line increases. And if I decrease it, actually the line changes its steepness and it flips around if the m number is negative. If the m number is equal to 0, the line is flat. So that's something very interesting. And note that if the m number is equal to 0, the place where the line crosses the y-axis is the same as the b number. Now if I change the b number, the place where the line crosses the x-axis will change. So note that if I decrease, the place goes down, and if I increase that number, the place where the line crosses the y-axis goes up. So the two meanings of those two numbers are that if I have, so my m number tells me about the steepness of my line, and it is called slope, and the b number tells me where the line cuts the y-axis, and it's called the intercept. You don't need to worry about this for the moment. It's going to become more clear later on. And this form of the line equation is just one of the forms. So we already know that line that goes through those 2 points has a form of y. Let me change the pen color to white. Is equal to y equals to 1 times x minus 1. So that's one form of the line equation. Sometimes it kind of makes sense to keep everything on one side and 0 on the other side. And if I do that, I'm going to move y onto this side and arrive at x minus y, and minus 1 equals to 0. So that's another form of a line equation. There are two that are cardinal. The first one is the slope-intercept, and the second one is the standard form of a line where I have x minus y plus minus 1. And we need to be aware of those two. And the third one, which I'm just going to introduce now for the time being, looks something like this. We take y variable and we subtract the coordinate of a point, and that should be equal to the slope multiplied by x minus coordinate of a point. In order to arrive at this equation, we need to have a slope and coordinate of 1 point. This is all foreshadowing for detailed explanation of the coordinate geometry that we're going to go through later on. For now, all I wanted you to be aware of is that the two of the fundamental shapes that we see on a coordinate plane are points and lines. Later on, we're going to learn about circles, but for now, those two shapes are sufficient. And now we know the way in which we describe these shapes. So let's just review what we learned about. We learned about points. We learned how to coordinate and read the coordinates of a point. We learned about lines and line equations. And in the next video in this sequence, we're going to take a look at points in a little bit more detail and start characterizing the relationships between them. So as always, thank you for watching, and this is Mr. Ozziak out.